So section 3.6 is talking about possible solutions, okay? But I want to trace back to what these ones are. If I'm looking at g of x and h of x, which one is the easiest one to factor?
G of x.
Why?
Because it has smaller numbers.
Right, and what's the leading coefficient?
2. Wait. No.
Leading coefficient's 1, okay? If a is 1, that makes factoring a lot easier, okay? So how can I factor this g of x equation? What do I need to look for first?
C.
I need to use that c value, negative 18, and find what? Factors of 18, what are they? 118, 9 and 2, 3 and 6. Okay, I think that's it. Which of those gets me to add up to negative 7? 2 and 9. Do I need to change them?
Yeah.
Which one?
Negative 9. I don't know.
I need to do the negative 9 because it's a negative 7. Okay? I picked my factors. How do I write my factored form?
X plus 2, X plus 9.
X plus 2, careful, X minus 9.
Minus 9.
Okay? On Thursday of last week, we talked about finding solutions. How do I find the solutions?
Find the 0.
Setting them equal to 0, okay? Or you can think I'm finding the zeros. Okay, so we set each of these equal to 0 separately. So I have x plus 2 equals 0 and x minus 9 equals 0. So what are my two solutions?
2.
X equals negative 2. X equals 9.
Yep, x equals negative 2, x equals positive 9. How do we know how many solutions we're supposed to get?
The exponent in the original equation.
It's the highest degree, okay? So we were supposed to get 2 solutions. Did we get 2 solutions?
Yes.
Yes. Do we remember what these 2 solutions are called? Two
Real solution.
real solutions, okay? If we didn't have all 2, where would the other ones come from?
Imagine.
The imaginary solutions, okay? I want to look at h of x now. Is that one as easy to factor?
No.
Why not?
You gotta do, because it has an actual number in front of it.
Right, it has an a value, so we would have to take a times c to find our factors, okay? Which we're used to being a longer process, right? Okay, today is going to help us narrow down what our solutions are, okay? So I want you to flip your notes to example 1. I want to focus on that graph real quick. Remember the solutions, are they our x values or they are y values?
X.
They're the x values, okay? How many x values do we have, or x-intercepts do we have on that graph?
4.
Where do you see 4?
You just count how many x's there are.
I see 1 here. Where's the other one?
Wait, what?
How many, where does it cross? Right.
I don't know.
Could you argue that it crosses here or here? Could you argue that if I zoom in here? Could you argue that it crosses at those points?
Sure.
Okay, because it looks fairly close, right? Okay, that's where these possible solutions come in. Okay, looking at this, how many solutions are we supposed to have?
5.
Where'd you get the 5 from? The exponent, right? We're supposed to have 5 solutions. Okay, so we want to list all the possible rational solutions. So how we're going to do that is we care about 2 things. I care about the leading coefficient, which is what?
8.
Yep, why 8? It's the highest exponent, okay? Or it's with the highest exponent. The other thing I care about is the constant. What is the constant? Constant is the one without an x value.
4.
Yep, so negative 4 is my constant. Okay, so with that, oh man. With the leading coefficient and the constant, we want to find the factors of both of those. Okay, so let's start with factors of 8. What are factors of 8? 1 and 8, and 2 and 4. What is going to help is if you write them in number order like this. Okay, I want to do the same thing with factors of 4. What are factors of 4? 1 and 4, and 2 and 2. So I want to write that as 1, 2, and 4. Okay, now to find our possible solutions, we have to take our constant, I want you to write that down, constant divided by leading coefficient. I'm going to abbreviate LC. Okay, you are going to have multiple answers. Okay, so what we're going to do is we're going to take each constant divided by each leading coefficient factor. So I'm going to take 1 divided by 1. What's 1 divided by 1? 1. What is, so I keep staying with the 1. What is 1 divided by 2? 1 divided by 2 is 1/2. Keep going. 1 divided by 4. 1/4. 1 divided by 8. 1/8. Okay, now I'm going to do the same thing, but I'm going to do it with 2. So now I'm going to do that same process with our 2. Okay, so 2 divided by 1 is, what's 2 divided by 1? 2 divided by 1 is 2. What is 2 divided by 2? 1. Do you agree we already have a 1? Okay, I don't need to write it again. Okay, so now I have 2 divided by 4. 2/4. What does that simplify to? 1/2. Do you agree we already have a 1/2? So do I need to write it again? No. 2 divided by 8. It is 1/4. Do I need to write it again? No. Now I'm going to do the same process with our last factor, 4. Okay. 4. 4 divided by 1 is 4. 4 divided by 2 is 2. Do I need to write 2 down again? No. 4 divided by 4 is 1. Do I need to write 1 down? No. 4 divided by 8. 1/2. Do I need to write that down? No. These right here are all of my possible values. Okay? What I want you to understand is that I can have the positive and negative versions of those for my solutions. Okay, now, Ansley had a good point. How many solutions are we supposed to have? We're supposed to have 5, right? Because it's the degree of our equation. We're supposed to have 5 solutions. What I want you to understand is we are finding all the possible values that it could be. Okay, so all the possible values to get our 5 real solutions, it will be 5 of those. Does that make sense? Okay, so right now we're not finding the solutions. We're just listing all the possible solutions that it could be. Okay? On this one, remember, we want to find all the possible rational solutions. What I want to ask you first is how many real solutions are there? Or how many solutions are there in this equation? Should be 4, right? But we want to list all the possible solutions. So could we have more than 4? Yes. Okay. What are the 2 things that I care about? Leading coefficient and constant. Okay. What is my leading coefficient? 4. What is my constant? -8. What do I need to find for both of those? The factors. What are factors of 4? 1 and 4, 2 and 2. So how should I write those?
1, 2, 4.
1, 2, and 4. What are factors of 8? 1 and 8, and 2 and 4. So I should write those as 1, 2, 4, and 8. Now we want to find all possible solutions. So what do I take divided by what? Constant divided by leading coefficient. Okay, so we're going to take one at a time. What is my first constant factor? 1. So I'm going to take 1 divided by 1 is 1. 1 divided by 2 is 1/2. 1 divided by 4 is 1/4. What do I do next? go to the next number, which is 2. So 2 divided by 1 is 2. 2 divided by 2 is, do I need the 1? No. 2 divided by 4 is, it is 1/2. Do I need to write 1/2 again? No. What do I do next? Move to the 4. 4 divided by 1 is 4. 4 divided by 2 is 2. Do I need to write the 2? Nope. 4 divided by 4 is 1. Do I need to write 1? No. Are we almost done? Yep, we just have to do 8 now. 8 divided by 1 is 8. 8 divided by 2 is, do I need to write it down? Nope. 8 divided by 4 is 2. Do I need to write it down? No. So what are all of these?
My possible rational solution.
Those are your possible solutions to the equation.
You gotta put plus or minus next to it, or will
I won't dock you for that, okay, because I know it's something easy to forget, but just understand that we could have the positive and negative answer of those, okay? Okay. Let's look at example B together also. Go ahead and get that one started. So on this one, I want to find all the possible solutions, okay? So what do we start with? What are the two things I need? Leading coefficient and constant. What is my leading coefficient? My leading coefficient is 7. And then what is my constant? Negative 45. What do I need to find for both of those? Factors, right? What are factors of 7? 1 and 7. That's it, right? What are my factors of 45? 1 and 45? 5 and
8.
5 and 9. What else? 3 and 15. Okay, so our factors of 45 are 1, 3, 5, 9, 15, and 45. Okay, so we have our factors. What do I do from here to find all of my possible solutions? I start doing the division, right? What do I start with? 1 divided by 1 is 1. 1 divided by 7 is 1 over 7. Now we do that process until what? We go through all of them. 3 divided by 1 is 3. 3 divided by 7 is 3 over 7. What's the next number? 5. 5 divided by 1 is 5. 5 divided by 7 is 5 over 7. Oh, I didn't mean to erase that. What's my next number? 9. 9 divided by 1 is 9. 9 divided by 7. I'll let you leave it like that. 9 over 7. Okay. 15 divided by 1? 15. 15 divided by 7? 15 over 7. Are we done? Nope. Almost. 45 divided by 1? 45. 45 divided by 7? Yes. Now are we done?
Yes.
Yep. So those are all possible solutions to my equation. How many solutions should we have from those?
4.
We should have 4, right? Don't forget, positive and negatives are an option.
This is actually kind of easy.
Good. Good. Flip to example 5 in your notes for me. Okay, in example 5, I want to talk about this one first. Remember the term conjugate. I had you do an example on that. So if I had 2 plus 5i as a root, we can say the conjugate of that is also a root. Okay, do you remember what conjugate is?
Opposite.
What's opposite?
The addition.
Right. So this turns from 2 plus 5i. That sign in front of our complex number turns into 2 minus 5i. Okay. So if this is a possible root of the equation, so is its conjugate. So looking at example 5 for me, 5a, it has 5 plus 4i as a root. What is another possible root it could have? 5 minus 4i. Similar with 5b, it has 2 minus the square root of 3 and 5i. Okay, what are the conjugates of both of those?
2 plus the square root of 3.
2 plus the square root of 3 and
Negative 5i.
negative 5i. Kind of seeing how this is working?
Yeah.
Okay, we've talked about conjugates before, so if you have one as a possible solution, you are going to have the other. Okay.